Welcome back to the TelecomTV Summit on the Green Network and our live Q&A show. I'm Guy Daniels, Director of Content, and this is our third and final live Q&A show of this year's Summit. Well, today's panel discussion looked at energy efficiency targets for new infrastructure, and we have already received questions from you on this, and some of our panelists are back with us now to help answer them. But there is still time for you to send additional questions. However, you do need to act fast. Please use the Q&A form that's right here on the website. And as always, your co-host for the Q&A show is Ray Maistre, Editorial Director at TelecomTV. Ray, this whole summit has looked at efficiencies and targets and best practices. And whilst green energy and alternative power sources are important elements, I'm really pleased that telcos are looking at a much broader range of solutions to enable the green network.
Yeah, absolutely, Guy. And thankfully, those solutions have been in development for quite a while already. We saw some of them at last year's MWC in Barcelona, for example. While we've also seen some power generation and storage technologies that previously were the reserve of developing markets, now being considered in the rural areas of developed markets too, which makes a lot of sense. The big challenge now, as network operators develop more distributed networks, is to do all of this in a way that doesn't cancel out what's already been achieved. I'm sure we're going to be talking about that during today's session.
Yes, absolutely. And it's going to be interesting to hear what our audience thinks about this. Thank you for now, Ray. Okay, let's meet our guests, and we have an absolutely stellar lineup for today's show. Joining us live on the programme are Sarwar Khan, who is Senior Manager for Global Digital Sustainability at BT Global. Beth Cohen, SDN Product Strategies at Verizon. Irene Zhang, Director of Product Marketing, Cloud, Metro and Security at Juniper Networks. Toyo Ibigbibi, who is VP Innovation and Strategy Energy at American Tower. And Maria Lema, who is co-founder of Weaver Labs. Hello everyone, it's really good to see you again. Lots of audience questions for us to get through, so let's get going, and over to you, Ray, for our first question.
Okay, thanks very much, Guy. And the first question from our audience today is as follows. The question is, what do you anticipate will be the impact of edge data centers on the profile of power consumption? So what kind of impact will edge data center proliferation have on power consumption network operators? Beth, maybe we can come to you for a response to this one first.
Yep, happy to address this. Obviously, telecoms in general are living the edge, so to speak. We have hundreds of thousands or possibly millions of access points, particularly if you figure in the infrastructure to support mobile networks. And so the way I see it is that certainly, it's a game of whack-a-mole, basically, which is that, as you move power out to the edge, you're reducing your power needs at the core. But at the same time, core power generally is greener and it's more efficient because, the core data centers can tap into, hydropower or other types of power that at the edge you have more limited access to. So I would say in general it's a wash.
Okay, it's a whack-a-mole wash. So that's it's a tough one to juggle there, isn't it? I mean, it's certainly going to have some kind of impact. We're going to come to Maria next and then to Toyo. So Maria first.
So I think it's a very interesting question, and I just want to chip in with some of the findings that we have had based on edge deployments for smart city applications. very much focused on the use of private networks. So when you go to the edge and you add that level of granularity, you also have more control over the power of those resources. And the fact that the edge kind of like distributes the whole network a lot more, you can act on the different level of resources that you have more independently than when you have more centralized deployments. Distributed networks will allow us to power on and off our assets based on the needs and the congestion. Therefore, edge can be a way to reduce power consumption when aided with a proper technology to do so, in terms of intelligent data gathering and also enforcing all of those decisions onto the elements of the edge. But definitely more granularity can help us distribute the workload better and be more intelligent on how we distribute the power resources as well.
Okay, thank you, Maria. And Toyo, let's come to you next.
No, absolutely. It's a fascinating question. I think two things that, from my perspective, are table stakes are the first is the edge is still nascent, and as both Maria and Beth have alluded to, there's smart city applications. There's you can think about it from a radio architecture network perspective as well. And some people argue that the edge is at the cell phone. So the point there being that the edge is still being defined as we think about this question. And the second one, it's very use case dependent. And so there are a couple of ways to think about what you will do at the edge from a data center or compute perspective. The first is what I've just mentioned, it's computing. And think about, from high-end analytics to basic network functions from a radio architecture perspective that require different levels of energy density. There's also storage. So think about your content distribution networks. Think about the ability to cache at closer to the customer or the end user. So you have lower latency and easier streaming or use of these platforms. And the third one is networking. And it ranges from high-end network functions to transporting. Think about optical fiber. And so when you think about all these three different use cases or modes of you deploying edge data centers, there's a whole bunch of applications that are still being developed. If you think about the metaverse, if you think about low latency and high-end gaming, for example, that are going to dictate the amount of energy consumption that are linked to this use cases. So a typical rack, at a core data center could range, depending on density, from about 5, maybe even 2, if it's really a low compute needs, to anywhere between 20 to 30 kilowatts of density per rack. And as you think about these different use cases and you start to distribute this infrastructure to the edge, it will be a game changer in terms of how we think about the energy consumption that will need to power all these different use cases. So I guess the first point is it's being defined. So there's going to be a lot of unopened or unanswered questions around the role edge data centers will play with energy efficiency. But as I can see from the way the industry is trending, the focus is on making these infrastructures that are deployed on the edge efficient. So that's a good start. And then the second one is it's going to be use case dependent. You could see edge data centers ranging from 100 kilowatts to up to a megawatt. So a massive range in terms of deployment, space availability, and capacity requirements. And what it will take is really an ecosystem of service providers, content distribution networks, infrastructure providers like the likes of American Tower, and other members. If you think about OEM manufacturers that produce these equipments and servers manufacturers as well, to come together to help define the edge and make it energy efficient as we evolve towards the edge.
Yeah, great answer there, Toyo. And I guess by the time we do get to a scenario of, tens of thousands of edge data centers in any particular market, the whole industry, from the chip vendors to the system vendors, the server developers, the application developers, everything will have moved on and much more towards greater energy efficiency. So really interesting one to track, and I'm sure we'll come back and talk about this at next year's Green Network Summit as well. Okay, fantastic start to the show. Guy, over to you for the next audience question.
Yeah, thanks, Ray. And on your last point there, I'm sure we will, because we've had several sort of related questions about the edge come in. So we'll definitely be following up on those. Next question here. We heard today on the summit of some smart innovations that can help with green network goals, plus the need for more software-based solutions. Is network optimization perhaps the easiest or quickest way, therefore, to reduce energy and emissions? Well, Maria, perhaps you could start us off with this, because we heard from you earlier, about an hour or so ago, about this very subject.
Yeah, sure. Happy to take this one. In terms of innovation that can help us be greener, at the end of the day, the software tools that the telecoms industry are building right now are helping us be more efficient with our assets. And efficiency goes hand in hand with, helping reduce the emissions and getting closer to the net zero approach that we want to get there. So at the end of the day, what software is going to give us is information and potentially the tools to act on that information in a form that we can act with a certain policy. And that policy can be, reduce power or direct traffic to areas where we have more access to renewable energy. So the point is that software can help us build that information gathering and act upon. The other thing that software can help us do is infrastructure sharing, which of course it's another way of reducing our carbon emissions and being more efficient, because we reduce the overbuilding. We can reuse assets that already exist and potentially are underused. And also we can increase the efficiency of those assets by having more tenants on them. So and software can help onboard customers faster. It can help us go into more infrastructure as a service business models and access infrastructure opportunistically where we need it. So definitely software is the way to go, because as much as we can look at being more efficient in where do we draw the power? We have little control on that, right? Like that is up to the energy sector to give us the tools on the renewable energies and the clean energy that we are consuming. But then what's on our agenda is to try and make the most with the resources that we have, and potentially looking at new deployments. How can we actually act on those resources in a much more efficient way? And if something we can learn from the cloud is that it enables us to be way more efficient, and all of that is based in software. So I'm a huge believer that actually software is going to be the way to go. And looking at the recent advancements on AI and how data fabric can actually help make all of these intelligent decisions, that's also based in software. So yeah, absolutely, software is the way to go, and network optimization will be a result of that.
Thank you very much, Maria. Sounds very encouraging indeed. Well, this question's obviously struck a nerve with a lot of you, because it looks like I think you all want to contribute and to this question. So first of all, let me go across to Sarwar for your comment, Sarwar.
Yeah, absolutely. I mean, just to build on what Maria is saying, you leveraging software, you actually gain visibility of assets you didn't have visibility of before, and that enables you to start making some informed action. So what are you actually optimizing for? The first one is, well, if you have visibility of devices that are sat there in idle mode, is there a better way of leveraging those assets? Is there a way of powering them down into the deep sleep modes? Another option is to optimize for matching with renewable energy on the grid. So as Maria said, data sources from the local grid providers will become critical, and being able to match when you run your networks, run your workloads and applications over the networks to match renewable energy on the grid gives you the potential to lower your overall carbon footprint. So I think software solutions is absolutely key, and probably the critical enabler actually to help towards organizations either reducing their energy consumption or working towards decarbonization.
Oh, interesting observations there. Thanks very much, Sarwar, for those. Irene, let's come across to you for your comments.
Yeah, definitely agree that software play a huge role, right? And in terms of whether optimization depends on how we look at it. One is for existing network with software that you can improve the utilization rate that and make it more efficient, or it can run it harder. That's one way. And the other is where if when you have software that allow you to apply sleep mode for parts that it doesn't need to be on all the time. And that way you can also save energy. Another point that I wanted to add is that when you have existing network with software, you can optimize to improve the energy usage. But don't stop there, because there's only so much. There will be certain percentage that you will hit, and that will be with software only. So as we think about long term, it's always important to think about how software and hardware and also the power supply, all things to consider for the maximum improvement for power efficiency.
Good point, Irene. We should not forget hardware there, and how hardware and software working together. It's all about optimization, it sounds. Thank you for those comments. Toyo, let's come across to you next, please.
Absolutely. I think that the points really resonate with me that some of the other panelists have brought up. The only sort of addition to the comments made that I would add is I'm beginning to see, and it less so in a 4G world, but certainly in a 5G environment, a lot of the software optimization historically, so this is pre 5G, has really been in microcosms. And if you look at it specifically, let's look at the telecommunications network, because it's carrier grade infrastructure and second to none. You look at the RAN and you look at the central offices and you look at the core, and they all somewhat operated, in microcosms, or they interconnected, but in terms of the efficiencies and the softwareization of that, that leads you to drive increased efficiencies, which will lead to lower energy consumption. I had historically seen that in microcosms. And the mobile network operators over the last couple of years, certainly not starting, anytime soon, have spent a lot of money and time and resources virtualizing their whole network stack from the core to the edge. And what that means is you're disaggregating, to the point that Irene just mentioned, the hardware and the software functions, and allowing for a lot more. Think about, the hyperscalers, the containerization of software applications and compute resources. And if you can disaggregate it, the software and the hardware components, such that you have a lot more efficiency all across the network value chain, your area under the curve to optimize increases. So that's the only comment I would make is it seems like the evolution of the network is with virtualization and software-defined networks are even pushing higher degrees of efficiencies on a broader scale as opposed to in microcosms, that would lead to a potential reduction in overall energy consumption of these networks over time.
Thank you, Toyo, for that. So taking more of a holistic approach across the entire network, rather than, as you say, more of a microcosm approach that we've seen in the past. Beth, let's come across to you to wrap up comments on this question then, please.
So there's been a lot of threads, and I think people have touched on, Irene touched on the hardware aspect, Toyo touched on the overall aspect, and Maria touched on the AI aspect, and I think that we're still very much at the beginning stages of tying these all together. And not to say that I'm not optimistic we'll get there. I think we're just not there yet. And so I've been working currently on some AI work around networking and networking efficiency. And with optimizing networks using AI, you need to know what you're looking for. And it's not clear that we do yet to know what we're looking for. Networks tend to work, have pretty steady state workloads. So yes, virtualization certainly helps, at least to a certain extent, by, maximizing the use of the hardware. But, virtualization does not really address, some of the other workloads related to changes in workload over time, which, networks don't work that way typically. So, the jury's still out, I think, in terms of being able to take advantage of AI to drive green efficiency. So, I'm looking forward to it, but I don't think we're there yet.
No, thank you very much, Beth. And I think it's been refreshingly honest throughout the 3 days of this summit that so many of our guests have said there's a huge amount of work still to be done. And we are still quite a distance away from knowing exactly what we need to do, let alone achieving it. Thanks very much for those comments, everyone. Ray, shall we move on to our next question?
Yeah, absolutely. And, I just want to say as well, great point from Beth there. The reason we're getting so many questions in for this summit is that there are so many questions still to ask, so much still to be done. So that's why we fully expect the Green Network Summit to be running for quite a few years yet. So let's move on to our next audience question, and that is, should all network operators be mandated to share their physical infrastructure in order to reduce the telecom sector's carbon footprint? Well, this seems like a bit of a devil's advocate question, but here it is. So let's start with Toyo.
Absolutely, and thanks for the question. I think, never really efficient to mandate anything really, because there are challenges in terms of the incentives and what are we trying to solve for individually and holistically. So I think mandate's a very strong word. What I will say about this is, I think, and Irene touched on this during the panel, which is there are business models that key operators around the world, so not just in North America, because the energy landscape globally, it does vary based on geography and regulation. There are key problems that operators are looking to solve. And for my landscape, I can boil it down to two. The first is energy efficiency and cost efficiencies linked to energy efficiency specifically. And the second one is sustainability. So making these assets, these networks, a lot more greener than they used to be historically. But what we have seen is sharing economics works to help solve for those two problem statements on a broader scale. Tends to be, case by case, as I mentioned, based on the geographic nuances and the operator needs, and whether you're deploying it at the back row base station or telecom tower, or you're looking at a data center or central office, for example. All the different needs of the operator need to be taken into consideration. But in a large, if you look at it in a broad brushed way, sharing economics does reduce the overall energy consumption. It does lead to the opportunities for you to deploy more green energy to support a broader base of customers than a single customer. And we've seen this with the tower infrastructure. But to the point that Irene touched on the panel, I say this only works if the business case works. It has to be win-win for both the operator and the vendor that is supplying a shared infrastructure solution to the operator. I think oftentimes people look for a solution trying to solve a problem, and oftentimes it leads to a lot of operators choosing to self-perform or do it themselves because whatever solution is put in front of them is not specific to their need. So I think for us to be able to go to a point where shared infrastructure from an energy perspective becomes more pervasive, vendors like the likes of towercos, like American Tower, or other infrastructure providers need to think about win-win business models that generate efficiencies for both, the vendor supplying that solution as well as the operator that needs that solution, to be able to really unlock the benefits that come with shared infrastructure, specifically within energy.
Okay, yes, great points there, Toyo. Thanks very much. And we've got a lot of panelists wanting to respond to this one, so we're going to come to Beth next before Maria. So Beth.
So I'm speaking from the telco perspective, and as Toyo mentioned, telcos are already heavily regulated, and be careful what you wish for. And I think that, as Toyo mentioned, mandate is a very fraught word. And we are actually motivated to be green for, there's plenty of financial incentives to reduce our footprint. So that alone can really drive it. But we also need to work hand in hand with the hardware providers, because we don't build our own hardware. We obviously buy it from other people or other companies, and the other companies need to be motivated to reduce the carbon footprint and reduce the energy consumption as well. So as was mentioned during the panel, we need to put it in our RFPs to say, hey, we're looking at, one of the criteria for buying your equipment is going to be, reduced energy footprint, because, maybe, your energy cost is a one-time cost, but our energy cost is an ongoing cost. So, for us to, so we get a higher value out of reducing the energy consumption of any given piece of hardware. So it's a business decision. And, we absolutely support the reduction of carbon footprint and higher energy efficiency, but I don't think it needs to be mandated.
Okay, great points there, Beth. Thanks very much. Maria, let's come to you next.
Yeah, I think it's a general sentiment that the word mandate, it's a little bit strong in this case. I believe in incentives, and incentivizing infrastructure sharing is what we should be doing as an industry. And from governments and regulators also communicate what is the good side of infrastructure sharing and where the incentives lie from an industry perspective, right? So there is, of course, a cost reduction, there is an efficiency of assets, there is the whole, wholesale model that it's very much outdated and slow. So again, bringing back the topic of software, it's how do we make all of these agile and flexible so that infrastructure as a service is appealing in order to fulfill with those incentives, which are cost reduction and efficiency improvement on the assets themselves. But it all comes down again to the business model. I don't think that the model of infrastructure sharing it's valid for the entire network, and infrastructure sharing is a model that it's good for certain areas of the network, and we should be flexible enough to adopt that model in areas where it is, and also, as Beth was saying, look at other ways of reducing carbon footprint with more efficient solutions when we do not want to share infrastructure in certain areas of the network by, having more control over the power consumption and having more control over those assets. But yeah, I guess the message here is less mandate, more incentives and competitiveness in the market, so that we are all pushing in the same direction rather than just pointing fingers.
Okay, great, thanks. And yeah, it'll be interesting to see what happens in Malaysia with the single 5G network that's going to be shared and how that'll pan out in the next few years. Sarwar, let's come to you next.
Yeah, thank you. I mean, what I would say is there really a need for something mandatory? Actually, many of the telcos around the world are setting net zero targets anyway, and many are aligning to the Science-Based Target Initiative, the SBTI. And as part of that, they're driving transparency. So one of the requirements there is to disclose scope 1, 2, and 3 emissions. And within scope 2, there's a requirement to look at the electricity usage across the networks and what percentage of that is covered through renewable energy. So there is already some level of visibility that is accessible to customers, accessible to investors and shareholders through initiatives like the SBTI and organizations reporting on net zero. Organizations also have the opportunity to report into external ESG type of platforms such as the Climate Disclosure Project, CDP, and they can provide the information in terms of electricity usage, percentage of renewables covering the electricity usage across their networks, across to their supply chain and to their customer base as well. And I think that route is probably the best way for driving telcos to provide that information.
Yeah, absolutely. Great point. So a great selection of answers there, and very clear from all sides of the fence here what the way forward would be in that kind of scenario, but also a very interesting question as well. So at this point, Guy, I'm going to hand back over to you for the next part of the program.
Yeah, thank you very much, Ray, because it's now time to check in on our audience poll for this year's Green Network Summit. 1 question, 7 answer options, and of course you can pick whichever ones you feel are the most important. And the question we are asking this week is, how can telcos most effectively reduce their energy consumption levels? And you can see the real-time votes right here. And of course, the numbers indicate the percentage of respondents who selected each option, which is why they don't all add up to 100. So, for example, we can see that an overwhelming 72% of respondents have said source more power efficient technology as a solution. And if you've yet to vote, then please do so, because obviously the more votes we get, the better. But don't delay, because we will close the polls tonight. And then we'll hand it over to Ray to analyse it on TelecomTV. Okay, talking of which, we've got about another 15 minutes or so remaining. So back over to you, Ray.
Okay, thanks, Guy. And it has been really interesting to see how the poll results have developed through this week as more and more people have voted. That source more power efficient technology from vendors option has been the most popular one from the get-go, but the votes have been creeping up all week for use AI and data analytics for real-time operations management. What's most shocking, of course, is that someone or more than one person has voted for the option do nothing. Energy efficiency plans are not ultimately beneficial. I'm hoping such votes have been cast for a joke. If not, then shame on you, I say, and we'll be sending Greta around to have a word with you if you voted for that. Okay, on with the show now. Next audience question, and here it is. And this one refers back to the executive interview that Guy conducted with Laurent Leboucher from Orange's Innovation Networks unit earlier in the week. And the question is, the Orange executive said that operators should extend the lifetime of their network equipment to make their networks more green. But does this really stack up? Isn't older equipment more power hungry? Harking back to that interview with Laurent from Orange there, Irene, maybe we can come to you first for this one.
Absolutely. So when we think about this question, we need to think about what's the overall objective. The overall objective is make the network green and make it more sustainable, reduce the negative impact to the planet, right? And so while power efficiency, energy efficiency is a very obvious way that we should optimize and consider and very clearly align to the objective. But sometimes there are also other ways to accomplish the objective. And if we overly only focus on one part, only focus on the power efficiency, we might lose sight of the others. So what I exactly mean by that is that for making the network more green or greener, that think about also how we use longer, like the components, the equipments in the network, that we can make it more sustainable and use longer. So while individually, the individual device may use higher power per se, and still, that's why measurement is important. Look at the numbers. But if you, instead of using the equipment and rip and replace every 3 to 5 years, if you can extend it and use it much longer for 5, 7, 10, or even 10 plus years, that way, that means that you don't need to rip and replace and buy a new one every couple of years. And think about it from an analogy. For consumers, like we all have phones and many of us have laptops and tablets. And one way that we can contribute to the planet and reduce our carbon footprint is, instead of replace those devices every 2 years, perhaps that we can use it longer. And also when we buy new ones, to consider how much longer that it can use, so that we can make more conscious decisions. So those are the things very important to consider. And another thing is that for those equipment, if it's only looking at the scale up option, then yes, it would be power hungry individually. But then if you transition to a scale out architecture where you add capacity horizontally, and that way you can accomplish the capacity and also adding on those new equipment and still remaining that equipment so that it extend the lifetime and you get to the bandwidth need, and also the power consumption will not be as hungry. So to summarize, it's important to consider it's not just overly just focus on the power, but also the overall with the reducing the e-waste by extending the lifetime of equipment.
Yeah, absolutely. And I think, just to hark back to that interview Laurent from Orange was referring to the carbon footprint impact, bringing everything into play there, and also talking at the same time about the reuse of equipment across the Orange group as well. So bring in an awful lot of factors there, but a really interesting discussion to have there. Great points, Irene. Sarwar, let's come to you next.
Yeah, I mean, this is a really interesting topic. Actually, if you look at the carbon footprint of a typical networking device, then 90% of the overall emissions actually sits in the in-use phase, i.e. so when it's consuming electricity, only 10% of emissions is allocated on average to the embodied emissions. So what is included in embodied emissions? In a life cycle assessment, you would include everything from raw material extraction through to the emissions embodied at the point of end of life. So I guess if the question, going back to, understanding the carbon footprint, really every operator or every organization who is looking at this, they would have to perform a life cycle assessment to understand, is there a way of reducing the in-use emissions? So is the older devices capable of going into deep sleep mode, low power modes, etc.? If it isn't, then actually it'd be more efficient to actually replace those with devices that have those capabilities, because again, going back to that 90% of where the emissions sit. On top of that, if you want to retain the devices in the network for longer to reduce e-waste, you could argue having 100% renewable electricity powering the networks would also contribute to lower emissions. So that's potentially another way around this and keeping devices in the ground for longer. But actually, many organizations now, including from a BT perspective, were able to return devices to vendors. There are schemes available and accessible for organizations to do that. And they can ensure that devices avoid landfill. They can either put it back into reuse or they can recycle it. And that actually gives you a positive impact on your carbon footprint. So overall, in summary, really, it's the truth is you have to assess on an account-by-account basis and perform that life cycle assessment to make a decision in terms of whether it's better to replace the device or whether to keep it in the ground for longer.
Okay, great points there, Sarwar. Thanks very much. We're going to come to Beth next and then to Toyo. So Beth.
So I'd like to add on to both Irene and Sarwar's points. They're often, and equipment that's been around for the last at least 15, 20 years generally has the capability of going into some kind of sleep mode, which of course reduces the power consumption, which gets back to, how do you do that? And of course, our earlier conversation about software, right? So software is going to be how you put the hardware into sleep mode or reduce power consumption. So that's how you can get more efficiency. And of course, there's another factor in the life cycle of maintaining the hardware for longer, which is, of course, there's a cost to replacing the hardware. Somebody has to, as we call it in the industry, truck roll. We have to send somebody out to wherever the equipment is located, where, particularly in where it's cell towers or a mobile network, it can be, scattered wherever, light poles, top of church towers. expensive places to send people to change out that equipment. And, energy expensive too, right? There's an energy cost to, putting somebody in a truck, driving out to the location, getting up to the top of the light pole, sticking it on, etc. So all of these do contribute to the cost of replacement. So there's very definitely a financial and energy efficient incentive to increase the length of the life cycle of that hardware. If we can increase it, from 3 years to 6 years, there's still significant reductions, particularly if we can use software to reduce the footprint, the energy use footprint of that hardware.
Yeah, absolutely. All great points there, Beth. Thanks very much. Toya, let's come to you for the final comment on this question.
Absolutely. I really enjoy the comments from the other panelists. The life cycle comment that Sarwar mentioned is one that I want to build on with a specific example. So in a previous role, I spent a couple of years in our Africa business managing our operations, where we do provide energy as a service there to our customers at our telecom infrastructure sites. And the life cycle of how you look at from a cost and also asset life and efficiency perspective really does help make these decisions a little bit clearer. So I'll give you a specific example. We were looking at replacing the backup batteries at our sites, and with the options of lead acid or lithium. Lithium, as we know, gives you a lot more functionality in terms of the ability to cycle. It takes a higher charging current. It has a longer life cycle compared to lead acid, and you could do a lot of things in terms of energy optimization with lithium versus lead acid, which has a sort of lower thermal runway and can lead to a lot of hazardous scenarios if not managed properly or at all. And one of the things we realize is if you look at it over a 3-year period, you're probably better off buying lead acid because of the cost of lithium, which is anywhere between 20 to 40% more expensive than some of these VRLA batteries. But if you look at the features that come with a longer lifespan, so if you look at it over a 10-year period, you could probably use that specific lithium battery for a longer life cycle. So the replacement cycles and the benefits of managing that new equipment over a longer period starts to kick in year 4, year 5, and in the outer years. So just a comment to say that, rip and replace is a question that often gets asked for multiple reasons, energy efficiency being one of them, cost being another, maximizing asset value and, return on investment on the capital, another one. But what I have seen is that life cycle analysis, if not duly considered, will make that decision a lot less accurate. Because oftentimes people look at it on a short-sighted or sort of a shorter window, largely sometimes linked to their contractual obligations, so they don't have a choice. But if you look at it on a longer-term horizon, over a longer life cycle, you begin to see a lot of the efficiencies that come with some of this newer equipment. So just a specific example to show how life cycle analysis helps with deciding whether or not rip or replace is a better energy efficient or cost efficient strategy for a network provider. Not necessarily answering whether one is a better one, but saying that there's a key variable to the equation that often gets underlooked, but makes a big difference in the overall deciding factor.
Okay, excellent responses there to that question. Thank you all for that. Great insights. Guy, back over to you. And are we starting to run out of studio time now?
We are, Ray. Thanks very much. We're almost at the very end. Only got a couple of minutes to go, so I think it's time for one of TelecomTV's legendary quick fire rounds. So as briefly as possible, please, so we can get some a range of responses in. Here's the final question of this year's summit. Are we starting to view energy efficiency as perhaps preferable to pure performance when it comes to selecting new telco infrastructure? So there's the question. Have we shifted from it all being about power and performance to actually just how efficient is this? Maybe this is a change we're seeing or not. Any of our panelists want to venture a comment as to whether that's actually happening in the industry now? Ooh, anyone at all? No? Maria, thank you very much. Let's go Maria first and then over to Beth.
Yeah, so I think at the end of the day, it's always cost. And it is about creating that the value between how much does it cost us to build and maintain a network and how much money are we making out of the network. So performance drives the cost on how much money are we taking out of the network from the service perspective. If we drive performance up, we should be able to sell more connectivity and therefore make more money. If we are more efficient with our assets and we drive power down, we're driving costs down. So I think at the end of the day, as an industry, we're trying to find the balance between how much do we invest, on the other hand, how much the return on the investment it's coming. So at the end of the day, it's the same question we're trying to answer, but from a different angle.
Nice. Thank you very much, Maria. Irene, I think you want to come in on this one as well.
Yes. So I would not say energy efficiency has replaced performance for vendor selection, but it is becoming very critical that we've seen over the last 2 years, for most or almost every RFP, that the energy efficiency has become a top criteria. And from what we heard, if vendor does not provide sufficient details about that, then it would not get selected, or it would not even proceed to the next step for the bidding process.
Oh, that's interesting insights, Irene. Thank you very much for that. So more importance given to energy efficiency. Beth, comments from you, please.
I'm from the telco perspective, and energy efficiency is certainly nice, but performance is still the overriding factor, I think. And I'll give you an example, which is PCs used to have 640K of RAM, and that was considered, amazing, we'll never fill that up. No. Whatever bandwidth we can produce, it will get filled up by our customers.
It certainly will. It's been going that way, hasn't it, Beth? Thank you very much indeed. Well, it looks like that's all the comments we have for that final question, which is handy because we are out of time. Thank you so much to all of our guests who joined us for this live program today, and to our audience for sending in those absolutely terrific questions. And that is a wrap for the Green Network Summit for this year. But Ray and I will be back next month for Spotlight on 5G.
Yeah, wow, time for yet another, our third Spotlight on 5G. And there's still so much to discuss, of course. We'll have our extra special 5G hats on during the next 4 weeks or so, and be reporting on all the main news from the show floor at MWC in Barcelona. Bring on the albondigas and Rioja, I say.
Absolutely. I'm going to place my order right now. So please join us next month for Spotlight on 5G, our online coverage of MWC. And until then, thank you for watching and goodbye.